Thank you very much, Heike, for this very neat introduction. Yeah, as you have been told, I work at the Leibniz Institute for Media Research, and for this reason, the research interests in our group usually are more like communication science or social science related, not so much linguistically related, but there is certainly a lot of overlap when it comes to analyzing textual data and social media data. So my talk for today is about similarity-based clustering and temporal visualization of tweets for detecting disinformation narratives. And we will see what this all means. So let's start with a little bit of an empirical example which introduces the topic. So we have here a screenshot from a debate of the German Federal Parliament, the Bundestag, from the 25th of March this year. And we see the member of the parliament, Steffen Cotré, from the right-wing party AfD. And he speaks a sentence like, "We also need to talk about the bioweapon laboratories in Ukraine that are targeted against Russia." So a member of the German parliament actually propagates first-hand Russian propaganda in the Bundestag. This is a kind of unusual situation because this whole narrative, this whole story that there are bioweapons in Ukraine, which have been financed and established by the United States and are a reason for Russia to fight this war in Ukraine. This whole narrative is absolutely bogus and there is nothing to it, but it has its origins a certain time ago, and it proliferated over social media and social networks, and from there to certain more prominent persons and influencers, and finally it has went also this narrative into this Bundestag debate. So let's see if we can trace this narrative and this debate, and this will be the major goal here of the talk I'm giving. But we will first take a little bit of a detour where I briefly introduce the project contexts from which this work origins, the Social Media Observatory, and the second project called Notorious. Then also highlight a little bit the importance of Twitter as a platform, why it is useful to look at Twitter, because this fits pretty good to the topic of this workshop here, I hope. And then we look at what people usually do with Twitter. They do analyze user networks, but our goal here is to create networks from actual content that is shared on Twitter and that is posted on Twitter. And we want to make use of this content and want to dive deep into this content to analyze a certain topic and narrative, and how we can do that is the main part then of the second half of this talk. And I hope we have an interesting discussion of this approach afterwards. So the project context of this whole work here is from two main projects. The one is, the first is the Social Media Observatory. That is an infrastructure project at our institute, where we want to systematically monitor social media communication of so-called public speakers. So we built an infrastructure where we, for instance, collect lists of public speakers. These can be mainly, for instance, parliamentarians or members of the government, media agencies, news agencies, and so on. And we build these lists together with their social media accounts, and then systematically monitor their activities on different social media platforms such as Twitter, Facebook, Instagram, YouTube, and so on. And second part besides this infrastructure is documentation. So we want to make sure that other researchers can replicate our methods and do their collections on their own. We provide also training for this and consulting for other projects. And then last but not least, have some steps of archiving of social media data together with our partner GESIS, where we want to make our data collections long-term accessible. So if you're interested in social media research in general, I want to advertise these two websites, mainly this SMO Wiki, for instance, where we publicly document our tools and our approaches to data analysis. And you are invited in a wiki manner, of course, also to participate and to share and contribute your knowledge there. Second project is the project Notorious, where we have the goal of identifying, monitoring, modeling, and modeling of diffusion patterns of disinformation. So here is not general public speakers the main focus, but disinformation in social media, which is a huge threat to societal cohesion and democracy, as we presume. And in this project, we look specifically at the role of prominent speakers, such as celebrities or politicians, and how they proliferate disinformation. So why should we actually look at Twitter? Why is Twitter important? So here we have a screenshot from the webpage Alexa, which has monitored the importance of websites worldwide. So it's a little bit outdated, since I noticed Alexa went out of operation in May this year. But at the beginning of this year, we made the screenshot where we see that Twitter is actually the 11th most important website in general. And if you look at the total sites that link to a certain website, then you see that this is even second place here. So there's only more links to Facebook, and Twitter is already second as a social network as compared in the number of links to the site. So this is, according to these numbers, one of the most important platforms, of course. And we also see a constant growing of monetizable daily active users, according to the reports of the platform itself. So this was also the heated debate of how many bot users are there, or how many actual users are there, in this recent debate of Elon Musk, who acquired Twitter and wanted actually to refrain from that contract due to the argument that a lot of these 217 million users are actually bots, but this could not be really proven. So we can actually assume that there are lots of very active users on the platform, and the bot problem isn't that big as it might have appeared in the past or in these official discussions. And then we can also compare a little bit about the usage structure of internet usage in Germany and link the platform to this. So we see, for instance, that 95% of German-speaking population of 14 years and more, they are online. And of these online users, we can also distinguish by different age groups and see that Twitter is not one of the most important, or not the most important platform. There is much more popularity of Facebook and Instagram, for instance, especially for younger persons. But we have a considerable size of 4% for adults, and for the younger groups of 14 to 29, we have an even larger group of, or larger share of users for Twitter. And these Twitter users are considerably different from users of other platforms, for instance. So in general, we can see that there has been a massive increase of the importance of social media and social media usage. This is very commonplace, I would say. But Twitter appears to be more commonly used as a news source, for instance, by journalists, and then compared to Facebook, and is also usually seen as a kind of elite channel. And we can also see this in the user structure. So Twitter users are in general younger, more highly educated, and wealthier than the general public. So why does this play a role for disinformation, or how has this been investigated so far? As a kind of elite channel, it is for us one of the most important platforms if we want to look at the role of prominent people, celebrities and so on, and their role of disseminating disinformation. And we see already in the literature that there has been very early signs of warning. So already in 2010, there was a publication which warned that Twitter can become a vector of disinformation. And since 2010, there have been numerous studies on disinformation on the spread and the context of disinformation in the context of national elections. So to name only two examples is here a study of the influence of disinformation in Brazil 2018 or Italy 2019. And we also have very specific case studies, for instance, disinformation about the taking Crimea by the Russians in 2014. This has been investigated more closely, how this was prepared and also accompanied by propaganda in pro-Russian Twitter accounts. And we also have this case of the Russia's Internet Research Agency, which is actually a real institution that has the goal of influencing social media debates in foreign countries. So if people want to investigate the role of information spread in Twitter or how information spreads, they usually look at user networks. And this is, of course, due to the network structure of Twitter itself. So usually we have directly observable network structures here, like follower structures. So a Twitter user account can follow other user accounts. And so you have two lists for each user, the lists of which users this user follows to, and another list of which other user accounts this user is followed by. And these structures can directly be translated into network structures for further observations and network analysis. Another popular way of creating networks is from retweets. So this is the question of which user actually retweets content from another user. So here we look more into interactions and not into the follower structures itself. And the same can be done with replies or ad mentions. So who is replying to whom and actually engaging in the debate. Or ad mentions is who is mentioning another user. And then you create these very large networks from this. So this is, for instance, a mapping of the German Twitter sphere done by a colleague of mine, Felix Münch. And he observed for the most popular accounts in Germany, several hundreds of thousands, the follower connections, and then can create, for instance, of this network, a network clustering and identify certain clusters of follower structures in this network. And by more closely investigating these clusters, you can then find that there are clusters about German politics, a large cluster of entertainment, of YouTube and gaming. Soccer is a major thing where people are following each other and discussing things, media itself. And then Austrian and Swiss politics, since we look at German language only here. And this structure actually is pretty similar also for other countries. So he did similar things for Italy or Australia. And you can find all these groups like politics groups, gaming, entertainment, soccer, or sports in general, also for the other countries. But we want to deviate now a little bit from these user-centered views on Twitter and want to actually look into the contents, because we want to investigate this Ukraine biolabs conspiracy a little bit more. And we do this by looking at tweets which were published from February to May this year in the context of the beginning of the Ukraine-Russian war. So our research question is, how can we effectively trace the spread and evolvement of disinformation narratives, such as the biolabs conspiracy, in social media networks? And one of the starting points of this conspiracy would be, for instance, this tweet, which we can somehow identify as one of the earliest if we look for this topic in Twitter with the generic search. And we see here a specific account who is tweeting that the US Embassy allegedly deleted important documents from their website, which reveal the existence of these 11 biological warfare labs in the Ukraine. And this alleged deleting of websites became one of the first incidents of making this narrative popular in social networks. And we see this account was actually created on September 26th, and the tweet is from September 27th, so one day later. And this is one of the first accounts which actually proliferates this whole narrative. And so how can we manage to investigate this threat and the evolvement of this whole thing from this beginning further? One idea is to start with a larger data set as a base population, and I can point here to some data set collection which we created as a result of our social media observatory work, the Ukraine Twitter data set. So this is also a collection started by Felix Münch and Philipp Kessling, and they started around in the beginning of the war to collect all tweets in English language with the hashtag Ukraine, and then also German, Russian, Ukrainian tweets with Ukraine not only as a hashtag, but as a general mention. So the reason why we do it for English only for the hashtag is just size. If we would not do it with a hashtag, then we would increase the amount of data 10 times as much or so, and that would actually be beyond our capacities of storing and computing. And then we also had a separate collection started for the term butcher to investigate more the communication about these war crimes happening there in the beginning of March. So this all in all collected around about 50 million tweets since the beginning of the collection. So up to 300,000 tweets, for instance, in English per day, no, in German per day, and for English it is 1.6 million tweets per day. And this is quite a lot, of course, but not all of this deals with our biolabs conspiracy. So actually, if we want to investigate more about this disinformation, we now need more algorithmic intelligence to do so. But the question, of course, is always like in disinformation detection, can actually algorithms detect disinformation? And the answer is no, of course. Of a tweet or a certain statement, at least not if it's not a very generic statement which can be accessed by a knowledge base or verified by a knowledge base. And this is usually the case for these public debates. So we cannot really assess the truth of a statement, nor can we assess the intention of the user. And disinformation also requires actually a bad intent to disinform. Otherwise, we would speak of malinformation or misinformation, for instance. But instead, we can use algorithms to detect patterns, and in the content and the metadata, we can score semantic similarity effectively, and we can, by this, also detect collaborative or coordinated user behavior. So this enables us to trace previously known disinformation or disinformation candidates, such as this biolabs conspiracy. And I just briefly introduce a little bit of working definitions here. We want to relate this a little bit to discourse theory. So in discourse theory, we have an idea of an utterance. This can be a single statement, or in our case, then a single tweet. Then we have the notion of a discursive event that can be a cluster of multiple similar utterances of some importance. And a narrative is then a series of important discursive events which are linked to each other via shared signifiers or a shared topic, basically. And last but not least, that can constitute a discourse where we have networks of narratives which are competing for hegemony among discourse participants. So to translate these working definitions into computational linguistic tasks, we want to actually measure tweet similarity. then cluster similar tweets, and get importance measures, for instance, for salience or dispersion over time of tweets. So based from our very large data collection of the Ukraine data set, we subselect the German tweets, which are 10 million tweets, and there we can also subselect only tweets which contain the term bio and the term lab in a case-insensitive manner. And we checked it that we get actually very good, precise, very precise results from that. So there are not many false positives in that selection by these matching key terms of bio and lab. And this leaves us with 32,000 tweets, which are dealing mostly with this biolab conspiracy. And then we want to have a kind of way to measure actually that a tweet saying, warum hat die USA Biolabore in der Ukraine? Or the English equivalent, for instance, why are these US biolabs in the Ukraine? And some question about the financing of these labs, that these tweets are actually to some extent similar or not by a certain percentage or score. So first, let's look a little bit about the frequency distribution over time. So we see that we can have that we have a kind of constant appearance of this biolabs thing in the Twitter data over time, but there are also a number of peaks which are very obvious. And it would be, for instance, very interesting to see what does happen in these peaks. And this graphic here also distinguishes between different tweet types. So we have actually original tweets, quotes in green, reply tweets in blue, and then in this purple color, the retweets. And we also see that the number of retweets is very high. So the retweets make up for more than 50% of this entire data set. So this biowebs conspiracy is actually proliferated a lot over networks, over the network, and not so much initiated again and again by new original tweets, but retweets make up a lot of amount here. So how can we now actually measure the similarity of what has been said? And we employ a method called sentence transformers for that. So you have heard already today, as I have heard about transformer neural networks and the BERT technology. And sentence BERT is actually a variation of this BERT technology and a state-of-the-art embedding methodology to get or to create embeddings that allow for similarity comparison of two inputs. So we have models and pre-trained models of sentence BERT available for more than 100 languages, and we can actually put in pairs of sentences or pairs of texts like two tweets and compute a similarity metric based on the resulting embeddings. So SBERT or sentence BERT is actually trained by this architecture, like a Siamese architecture. We have one BERT here and one BERT here for the second instance, and we can input two sentences at the same time into the left and the right part, and in the end then get the resulting embeddings and a softmax classifier. And the pre-training procedure takes the SNLE dataset, which has annotations of like these sentences are related to each other, or neutral against each other, or contradicting each other. So this, by classifying this relation between two sentences, the embeddings are transformed in a way that the more similar the sentences get, the more closer their embeddings get. And we can, in the end, then use this whole architecture in the prediction step to just get the embeddings out of the pre-trained model and compute a cosine similarity on these two computed embeddings. And this gives us a score of -1 to 1, which actually indicates the similarity of two sentences. So if we look at the distribution of sentences, the similarity scores, we can see that we have actually a very few sentences which are very or very few tweets in our data set which are very, very similar, which have a 70% or higher similarity. And then most of the similarity scores are here in the range of 0.5 and going on. So I skipped everything below 0.5 as not worthy of comparison at all. But the question now is a little bit of what's a threshold to select here for actually similar tweets or not. And we, of course, have to do a little bit of pre-processing as well. So we remove retweet indicators, URLs, add mentions, and so on, and have in the end left only 3,500 unique tweet texts by that, for which we can, for all pairs, compute the similarity. So take care that we have actually a quadratic runtime here. So for larger data sets, this can be quite compute heavy, or maybe infeasible even to compute, for instance, for tens of thousands or hundreds of thousands of tweets, all the pairs. Now we want to create a network graph from these tweets. In this network graph, nodes are our unique tweets. And the edges are drawn if two tweets are at least similar to 75%. This is a little bit of an arbitrary threshold, so actually we need to experiment more with that, but it worked out in the first evaluations as a good value for us. And now we can also make this edge directed, mainly in the direction of time. So the earlier tweet, so from the later tweet to the earlier tweet, we can draw this direction or this arrow in the graph. And then we have a network based on this, and we can perform network analysis to identify clusters of similar tweets within the graph, for instance, with a random walk algorithm. And we can assess the salience of single nodes. And this we can use with the PageRank algorithm, which we have already learned about by Adrian before. So this can help us to identify important nodes in a network. And last but not least, we can visualize then this graph structure either as a graph or in our time, again, as a temporal visualization. And I did this with ggplot and the plotly library in R. So let's have a look into the first visualization of this clustered graph. And as you can see, you cannot see very much. So we have here our 3,500 tweets in different similarity clusters. And this network visualization is kind of hard to read because, of course, there's lots of data in it. And also it's not very handy. And the cluster structure is maybe also even, or the graph structure, not very intuitive. But let me switch to this view here in the PDF viewer, where I can at least, for instance, zoom into the number of clusters, and I can actually validate that these clusters talk about the same or similar stuff. So here, for instance, we have a number of tweets where kind of flight of a Canadian general is mentioned, and this person is apparently involved in the biolabs, or we can see a lot of other events in the data that apparently are talked about in a very similar way that we can investigate. But as I mentioned already, this cluster or graph structure isn't probably the most helpful one. So let's try if we can get the time component back into this. And here we have a variation of this data in our plotly plot as an interactive plot. And we see each point in this graph is a tweet, and the colors indicate the belonging of the tweets to the same cluster. So all pinkish bubbles here, for instance, are tweets of the same cluster. And we have, they are arranged on the x-axis by time. So we can see it starts everything in the end of February and goes up to May in our dataset. And the y-axis indicates the measured salience by page rank. So for each cluster, for instance, we can see which is the most important tweet that can be seen as a kind of representative tweet that describes this cluster. So let me start, for instance, with these very first cluster here. And this is, if I hover over the highest data point here, we can see a tweet text mentioning the US is having biolabs in the started to create biolabs in the Ukraine, of course, only for defense purposes. In a kind of sarcastic way, this is mentioned. And we can see that these green points are highlighted more or less throughout the entire timeline. So we have also this, this similar tweet of the US and Ukraine work together to have not taken over these Russian biolabs, this Ukraine biolabs by the Russians. So this is the similar mentioning in the 8th of March for this. And in the end of April, for instance, there you find also a similar thing which mentions bioweapon laboratories in the US, which are existing, but the US is not, and the US allegedly also announced that this existence is actually true. So we can see this very similar basic notion of this narrative over time in the entire time frame, but we can also see a different pattern like this pinkish one here, where we have only similar tweets occurring over a very short period of time and very dense and condensed way. So here this means, for instance, the US Embassy just deleted all the documents about the bioweapon laboratories in Ukraine from their website. So this whole pinkish cluster deals with this specific event of these documents from the US Embassy website. And this only lasts for a week or so in the data. We can also see other single events like this red one here. This is related to the Chinese Ministry of Exterior, which is officially making a response on the biolabs conspiracy and wants the US to release some documents. And we also have, for instance, in the 17th of April, this very short cluster, which contains the information that actually Moscow itself announces that Germany is part of this biolabs conspiracy and is actually participating in creating bioweapons. But this is only detectable for 2 or 3 days in the data. So we can actually observe lots of these different events, and some of them are dispersed over time and some are not. So this is an interesting pattern or an interesting fact that we can also make sure to investigate more closely. So we alternatively visualize a little bit this plot by not displaying time on the x-axis, but temporal dispersion. And we represent each cluster by its most salient tweet. And we represent cluster size by node size. And this gives us the opportunity then, for instance, to have this kind of graph where we can see the higher on the y-axis, the more salient a cluster is, or the more salient a tweet is, and the more right on the x-axis, the more dispersed it is over time. And actually, this gives us a little bit a distinction of more narrative events or more actual events in the data. So we have this deleting of websites is more on the leftish side. So this is very close, a very short period of time. Or there's another cluster which only was active for 1 or 2 days, which talks about inhuman experiments which are conducted in Ukraine in these biolabs, and Russia is accusing the Ukraine of doing that. and that only lasts for 2 days or so. And we have this generic or general mentioning of the US biolabs in Ukraine, which is on the far right side here, which is the overall narrative, which can be seen entirely throughout the data again and again. So this is our proposal on how to actually analyze the data, and then we can look more closely and more qualitatively on those specific events and how they evolve the entire narrative over time. So let me come to the conclusion on this biolabs conspiracy. We can see that this conspiracy narrative gets continuously new material, and the spread of this new material seems coordinated, not really coordinated by central actors, but initiated by some actors, and then kind of a crowd of users who are actually willfully spreading those information, share this information in Twitter. Fact-checking websites have a hard time to actually deal with all these new parts or new events of the narrative coming up. So it actually is a kind of tedious work to debunk every single information which comes up by these disinformation actors. And we can also see that we do not observe a very consistent recurring counter-narrative in the data. So this is actually something which is missing and which could be improved to counter this propaganda stuff, that we actually also see a counter narrative again and again repeated in the data. And potential recommendations for how to deal with this could be that we strengthen this general counter-narrative instead of refuting ever new individual rumors, and also use a kind of pre-bunking strategy as immunization. So if we see something coming up, we can say we could publicly announce this might be the next thing which our disinformation spreaders are spreading, but be aware this is not true. From the methodological point of view, we can summarize our lessons learned that we can use semantic embeddings like SentenceBird to identify similar clusters of tweets. This is pretty impressive, actually, what SentenceBird is able to do there. There are even multilingual models which are able to cluster similar English and German tweets, for instance, so we can extend our German-related discourse analysis to multilingual discourse analysis. There are network analysis procedures which are useful to rank tweets by their contribution to the discourse. And we can cluster ranked tweets and display them over time to reveal the evolvement of narratives. And this serves as a very useful selection approach for further qualitative inspection and qualitative research on the subject. But there are also a lot of open questions and things to do. So one question is, how can we actually evaluate this method more systematically? What are optimal thresholds, for instance, for linking similar tweets? We chose 75%, but maybe it's better to take less similar tweets also as similar into account. What are optimal network clustering and node ranking methods for the task? So I chose these PageRank and random walk more like ad hoc measures, but due to the lack of a systematic evaluation, I don't know if they are the best ones. How to distinguish between affirmative and dissenting references. This is very important because now everything is treated the same. So if there is a tweet, there are no biolabs in the Ukraine, this will also end up in our general cluster for the moment, but not detected as actually a debunking tweet. And that could be interesting to distinguish these types, of course. And then the question is, can we find types of accounts spreading disinformation as initiators? This is quite straightforward, and we are already working on that. And the question is, can and should we connect this more systematically to discourse theory or other theoretical backgrounds? And I would be happy, of course, also to discuss some of these questions with you. Thanks for listening.
Gregor, I suggest to keep the slide sharing on, because
all right, yes.
Otherwise we would record the room. Okay, so Marcus, could you check what is on the recording laptop? Because then I could share room view here. Is there still a speaker?
No, it's the room right now, because it's. But you can just switch the camera and build back out of the and then we'll see. So we are also repeating the questions.
Mm-hmm. Okay. So, okay, but then Gregor cannot see the room either.
No, this is not possible.
Okay.
It's not. So if you can't record the room and show the room.
Okay, but so we cannot do different things on the two different laptops.
Unfortunately, no.
Okay, good. Okay, so thank you very much, Gregor. The room is open for questions. So I have a question. So the deletion, when you showed us these, for example, temporal, when you showed us the temporal visualization, was it deletion of tweets or deletion of accounts?
I'm a little bit confused about the term deletion. What do you mean by deletion?
You said that there were, to the left side of the graph, there were, and I couldn't grasp it, whether it was the tweets that had a short life or the accounts.
Ah, okay, so this is temporal dispersion. So this means how far are they spread, the different clusters spread over time. So let me maybe explain this again. So we have this greenish cluster here, or the
the end of the spreading is caused by tweet deletion, or
no? This is not deletion. This is simply, so let's say we have here this green cluster on the current plot, and the green cluster first starts in the 25th of February. And one of the last tweets is here in May. And lots of the different tweets are lots of tweets of that same cluster are in between. So here this is quite dispersed over time. So we see this whole this single piece of information, or this very specific thing of information transported in this cluster is reoccurring once and once again over the entire period of 3 months. And then we have a different cluster type, which is this one, where this is an example for, and here tweets of this cluster exist only, they exist only, they were tweeted for about only 2 or 3 days. So after 2 or 3 days, no one gets this or takes up on this part of information any longer. So this kind of dies out in the discourse. And the whole visualization of this, or the second part here is then like, these are dying, these pieces of information are dying out quickly in the discourse. And this on this right side, you can see this appearing again and again throughout the discourse. So this is something which sticks, and something which people relate to over and over again. So this gets more a narrative character, and this stays more on the event part.
Thank you. It was a misunderstanding on my side. Questions? Then technical question. So the interactive plot that you showed us with the temporal information, that is created by ggplot2 and something else, or is it?
And Plotly, yeah. So this is together with Plotly. Plotly allows you to extend interactive elements into a ggplot graph. And this is, yeah, quite useful for these more complex things where you have a lot of, for instance, qualitative information like these texts, which you want to link as kind of background into this. So it would be very, yeah, uncomfortable or even impossible to actually plot this directly into the graph, but make this hoverable surely allows to create this or to get this complex metadata and the underlying data into the visualization itself. So I can really recommend also this Plotly extension to create these more complex things.
Thank you. Yannis?
Yes. Will you repeat the
I will
question?
repeat the question.
I have two short questions and a
Or maybe we could try this.
remark. Yeah, let me try this. Können Sie mich hören, das Mikro? Herr Wiedemann?
Gregor, kannst du das hören?
Nochmal. Yeah, try it again.
Wie ist es jetzt?
Yeah, I think it's possible.
Okay, that's good. So the remark of the comments is that for the connection to discourse theory or discourse analysis, the description you gave just before with the other graph could be useful or a way ahead. So I think an interesting aspect of this study from a discourse analysis perspective would be how certain statements within this discourse persist and gain institutional authority over or through being repeated and reformulated and spread from type of speaker to other types of speaker. So if you could identify that, but that also would mean identifying speakers and speaker type and speaker positions. So if you could identify the moment where one of these statements or this statement, or the propaganda statement, the disinformation statement, jumps over to members of parliament. Okay, so that would be interesting to see how this information not just spreads quantitatively and over time, but sort of scale jumps from less to more institutional positions, right?
Yeah, thank you very much for this comment or idea. Actually, this is something which we, let me try if I can switch back here. Yeah, which we also try a little bit in the context of our Notorious project, where we actually want to investigate this role of celebrities, prominent speakers, public speakers, and so on, and how they contribute. And as a very first approach to this, we very ad hoc decided popularity on social networks as a kind of prominence criterion, and for instance, introduced two types of regular, one type is regular account and the other is celebrity account. And the distinction criterion is if they have more than 5,000 followers on Twitter. And then we wanted to encode this in this graph also, and we try to do this a little bit by these different circles or rectangular shapes here to see if we can so the rectangular shape indicates a kind of prominent account which has a lot of followers, and we can see that most of the time these information pieces are shared or introduced newly not by prominent accounts but by regular accounts, and then very rarely at the moment these prominent accounts show up in the data. And they also are not among the first and early adopters usually of this pieces of this information. But we need to further investigate how they play a role in further spreading, of course. So here we look definitely more into where the information comes first from, but not so much, since we exclude retweets and so on, not so much in the spreading, and we presume that they play a more key role in spreading this information further to other circles, but not so much in initiating these disinformation things. So this is at least a very early preliminary result we can get from this here, but this is certainly a good point also to link this role of actors and the types of actors together with the ideas or theoretical backgrounds to Discord theory.
Thank you very much. This is very interesting. I have two very brief questions on that. The first is whether you're able to filter out bot accounts, and the second is how you identify counter speech if that counter speech does not include the keywords.
Yeah, so this is actually, so this was one of the open questions with counter speech or debunking, so we do not deal with that yet. We simply argue that also counter speech taking up on a certain issue, although debunking it or countering it just takes up on this issue, and we count it as an event in our data like the others. But certainly it would be more interesting to see, for instance, if counter speech helps to that the proliferation is less strong in the data, or how people react to this. So this is something which is still open, and I think we can probably use some technologies from the field of argument mining here, where we also have classifiers trained to distinguish between pro and contra arguments, and that approach can also certainly be transferred to the idea of classifying, distinguishing between affirmative and dissenting mention of a certain issue. So that would be some work package which we will do in the near future. And the first question was related to, I forgot.
Bots.
The bots. Yeah, the bots. So currently we do not deal with bots or bot detection because this is something very complicated actually, so there is not really a reliable tool out there which can reliably or validly identify bots. There are some public tools, but their quality has been severely questioned in the recent research public, and so we refrain from using them. And in this work here specifically, this is also not the major problem, because we only look at unique tweets here. So we exclude retweets and exact copies. And usually the bots operate on these very low levels of intelligence, that they just copy certain contents. And so they will not play a very significant role here. Only maybe in the size of these circles, which I did not mention so far. The size of the circles in this plot, for instance, indicates the number of retweets which a certain piece of information had actually in the Twitter network, which we observe. And that can, of course, contain a lot of retweets by bots, but we do not check for this.
Thank you very much. Are there further questions? Seems like everyone is hungry right now. Okay, so then I'd like to thank you again, Gregor, or we'd like to thank you.
Yeah, thanks a lot as well that I could join you from my home office